Hello everybody, so today I will talk about calculus. The topic today is about differential equations. So now I will show you how to answer. I will put about b equals to this one and q equals to this one. So because we have the x, that means we do first the derivative of b with respect to y. So we have y, and y squared in here. So this one we have x plus 1 plus 2y. Next, we have dy. So we need to do first the derivative of q with respect to x. So we just have only this one in here, and that is about number 1. So we see that this one is not equals to this one. So we need to use about integrating factor. We see that we need to choose about mu x because this one we have x plus 2y and this one we have x plus 2y in here. So that's why we need to choose about mu x to cancel about x plus 2y. That means we multiply both sides by this one because we want to transform into exact. So the new one we want to put about dy or dp over dy equals to dq over dx. Now this one we just have only y, so you will have that's about x plus 1 plus 2y, and we have mu x. This one, if we do first the derivative in here, we need to do first the derivative of mu x multiplied by x plus 2y plus mu x, and this one we have number 1 because first the derivative of x we have number 1. This is not about x, that's why you got about 0 if we do first the derivative. And now we need to simplify. So mu x number 1 we put on the left. So 1 minus 1 we cancel. Next, we simplify x plus 2y for the both sides. Later that we divide both sides by mu x. Next, I will put the integration for the both sides. So the integration of this one we have number 1. The integration of this one we have ln of the absolute value of mu x. So this is about s, not number 1, sorry. So about s, that is about ln e to the power of s. So in this situation, mu x equals to e to the power of s. That means we change mu s into e to the power of s when we multiply for the both sides. So I will put about b equals to this one and q equals to this one. So we need to put about db over dy. So we have like this. Now about the next one, we have like this. And this one, if we do factorization, that should be like this. And we see that this one is equals to this one. So that is about exact. And now we need to use about the integration in here. So we need to set up about fsy equals to the integration of this one plus gsy so we have e to the power of s multiplied by this one, and this one we will have another, that's about e to the power of s multiplied by y plus y squared in here. Now I will concentrate about the integration s e to the power of s. So we need to use about integration by parts. So I will put about u equals to s. Later that we do first derivative for the both sides, and we have the u equals to the s, the v we have e to the power of s, the s, the integration of this one we have v equals to e to the power of s. So we have u multiplied by v, s e to the power of s minus we have the u multiplied by v, so we have the integration e to the power of s ds, and this one we have negative e to the power of s, and I will put about c. So we go back in here. The integration of this one we multiply by y, so we have this one in here. The integration of this one you keep the same. And now y we multiply by this one, e to the power of s multiplied by this one. Now we need to simplify this one. Next, we need to do first derivative of the function with respect to y for the both sides. So we have y in here, so we have s e to the power of s. This one we have 2y. And we know that everything in here equals to this one. Oh sorry, this one. And now we simplify for the both sides, and you got about 0. Later that, we put the integration for the both sides. And this one we have C. Now we go back to this one in here. So there should be about from here. We see that xy in here, that is about xy. After doing the integration in here, and we change xy into C, and this one equals to fxy equal to C, and now we just simplify like this. And this is the final answer. This is the end. Thank you for watching.